What if I told you that right now, at this very moment, 4 human beings are sailing through the darkness of space, farther from home than anyone has traveled in more than half a century? Deep in the vastness of space, a small capsule no larger than a family living room is carrying 4 astronauts on a journey that humanity has not attempted since 1972. For over 50 years, the moon has waited in silence, its craters and valleys untouched by human presence, its far side unseen by human eyes since the days of the Apollo missions. And now, after decades of dreaming, planning, setbacks, and triumphs, we are finally going back. This is the story of Artemis II. And what makes this mission truly remarkable is not just that we are returning to the moon, but how we are doing it, and who is making the journey. Let's take a moment to imagine something extraordinary. Picture yourself standing on a quiet beach at night, looking up at the moon. It looks so peaceful, so close, almost like you could reach out and touch it. But the moon is roughly 240,000 miles away, a distance so vast that it would take you about 4 months to drive there in a car, if such a thing were possible. Now imagine climbing into a spacecraft and making that journey in just a few days, looping around the moon's far side, the side we never see from Earth, and then riding the pull of gravity all the way back home. That is exactly what Artemis II is doing. Scientists have recently uncovered something extraordinary through this mission. A new chapter in human exploration that changes everything we thought we knew about our return to the stars. As we journey deeper into this mystery, you will discover why it took us so long to go back, what incredible technology is making this possible, and how 4 remarkable individuals were chosen to carry the hopes and dreams of an entire planet. So settle in, relax, and let the gentle hum of the cosmos carry you along as we explore one of the greatest adventures in human history. The story of how we finally found our way back to the moon. To understand this mystery, we need to travel back in time, all the way to the golden age of space exploration. Between 1969 and 1972, NASA's Apollo program achieved what many thought was impossible. 12 American astronauts walked on the surface of the moon, collected rocks, planted flags, and gazed back at our pale blue planet hanging in the blackness of space. Apollo 17, the final mission, lifted off from the lunar surface in December 1972. Commander Gene Cernan was the last human to leave footprints in the moon dust, and as he climbed back into his spacecraft, he promised that humanity would return. But decades passed, and we didn't go back. The reasons were complicated. Budgets shrank. Political priorities shifted. The space shuttle program took center stage. And slowly, the moon became a memory rather than a destination. As we venture deeper into this story, let us explore what changed. In 2017, NASA officially announced the Artemis program, named after the twin sister of Apollo in Greek mythology. The goddess Artemis was associated with the moon, making the name a beautiful and fitting choice for this new era of lunar exploration. The program's goals were ambitious from the start, not just to visit the moon again, but to establish a lasting human presence there, to build a space station in lunar orbit called Gateway, and eventually to use the moon as a stepping stone for missions to Mars. But turning these dreams into reality would take years of engineering, testing, and patience. What we discovered along the way was both humbling and inspiring. The first major milestone came in November 2022, when NASA launched Artemis I, an uncrewed test flight that sent the Orion spacecraft on a journey of 1.4 million miles around the moon and back. The mission lasted 25.5 days, and it proved that the spacecraft and the massive rocket that carried it, called the Space Launch System, or SLS, could survive the harsh environment of deep space. But the mission also revealed challenges. Engineers discovered that the heat shield, or the protective layer that keeps the spacecraft from burning up during re-entry, behaved differently than expected. Pieces of the shield's outer coating came off in ways that were not predicted by computer models. This discovery led to months of careful investigation. NASA Artemis program. These investigations, combined with concerns about the spacecraft's life support systems, the technology that keeps astronauts breathing and comfortable in space, caused the next mission to be delayed several times. Originally planned for as early as 2024, then pushed to September 2025, Artemis II was finally given a launch date of April 2026. Some people grew frustrated with the delays, but NASA's engineers understood something important. When you are sending humans to the moon, there is no room for shortcuts. Every bolt, every wire, and every line of computer code must be perfect. And so they took the time they needed, because the lives of 4 extraordinary people depended on getting it right. As we continue our exploration, let us talk about the incredible machines that make this journey possible. At the heart of Artemis II is the Space Launch System, or SLS, the most powerful rocket ever built by NASA. Standing taller than the Statue of Liberty at 322 feet, this enormous machine produces 8.8 million pounds of thrust at liftoff. In simple terms, that is enough force to push something weighing more than 45 fully loaded jumbo jets straight up into the sky. The SLS is powered by 4 main engines, the same type that once powered the space shuttle, along with 2 massive solid rocket boosters strapped to its sides. When those boosters ignite, they burn through 6 tons of fuel every single second. Can you imagine that? 6 tons every second. The roar of this rocket at launch is so powerful that it can be felt in your chest from miles away. A deep rumble that shakes the ground and fills the Florida sky with a column of brilliant fire. Sitting atop the rocket is the Orion spacecraft, the capsule that actually carries the astronauts. Orion is a marvel of modern engineering, built to withstand the extreme conditions of deep space. It has 2 main parts. The crew module, where the 4 astronauts live and work, is roughly the size of a large van, cozy, but equipped with everything they need for a 10-day journey. Behind it is the European Service Module, built by the European Space Agency, which provides power through massive solar panel wings, propulsion through its main engine, and the systems that supply air, water, and temperature control. What makes this discovery truly remarkable is that Orion also carries a brand new laser communication system, a kind of super-fast space internet that uses beams of light instead of radio waves to send data back to Earth. This technology can transmit information up to 100 times faster than traditional radio, meaning the crew can send back stunning high-definition video of their journey almost in real time. The implications of this technology are staggering. This new communication system is not just useful for Artemis II. It represents a breakthrough that will transform all future deep space missions. Imagine astronauts on Mars being able to video call Earth with barely any delay, or scientists receiving crystal-clear images from spacecraft orbiting distant planets. The Orion spacecraft and its SLS rocket together represent the most advanced human spaceflight system ever created, a testament to what we can achieve when thousands of engineers, scientists, and dreamers work together toward a single, audacious goal. And as we venture further into this story, the technology only becomes more extraordinary. Now, let us meet the 4 incredible people who are making this journey. What we are about to discover will amaze you, because the crew of Artemis II is not just a team of astronauts. They are a living symbol of how far humanity has come. Leading the mission is Commander Reed Wiseman, a former United States Navy test pilot who previously spent 6 months aboard the International Space Station in 2014. Wiseman is known for his calm demeanor under pressure, his sharp technical mind, and his ability to lead a team through the most challenging situations imaginable. As commander, he is responsible for the safety of the crew and the success of the entire mission. Serving as pilot is Victor Glover, a former Navy fighter pilot and test pilot who flew aboard the SpaceX Crew Dragon spacecraft in 2020. Glover is making history as the first black person to travel to the moon, a milestone that carries profound significance for millions of people around the world. Scientists have recently uncovered something extraordinary about this crew. Their diversity is not just symbolic. It represents a fundamental shift in who gets to explore the cosmos. Christina Koch, one of 2 mission specialists, is an engineer and physicist who holds the record for the longest single space flight by a woman, spending 328 consecutive days in space. She also participated in the first all-female spacewalk in 2019. Koch is now becoming the first woman to travel to the moon, breaking a barrier that has stood for the entire history of human spaceflight. The 4th crew member is Jeremy Hansen, a former Royal Canadian Air Force fighter pilot and physicist from the Canadian Space Agency. Hansen is making history as the first non-American to travel to the moon, representing not just Canada, but the international spirit of cooperation that defines the Artemis program. The implications of this crew selection reach far beyond the mission itself. For the first time, a journey to the moon reflects the true diversity of our species. Young girls can now look up at the moon and know that a woman has been there. Children of all backgrounds can dream bigger because the barriers that once existed are falling away. This discovery changes everything we thought we knew about who gets to be an explorer. And as these 4 brave individuals hurtle through the darkness of space, they carry with them the hopes, the dreams, and the boundless curiosity of every person on Earth who has ever looked up at the night sky and wondered, what is out there? As we journey deeper into this mystery, let us trace the path that Artemis II follows through the cosmos. The mission launched on the evening of April 1st, 2026, from Launch Complex 39B at Kennedy Space Center in Florida. The very same launch pad complex where Apollo missions once began their journeys to the moon. After the thunderous liftoff, the SLS rocket carried Orion into a low orbit around Earth in just minutes. But the journey to the moon did not begin immediately. Instead, the crew spent time in a high, oval-shaped orbit around our planet, one that took roughly 24 hours to complete. During this time, they carefully tested all of Orion's systems: the life support, the navigation, the communications, making sure everything worked perfectly before committing to the long voyage ahead. They even practiced flying close to the spent upper stage of their rocket, a maneuver that tested their ability to navigate precisely in the weightlessness of space. Then came the moment that changed everything. On day 2 of the mission, the crew fired Orion's main engine in what is called the translunar injection burn. In simple terms, this is the big push, the moment when the spacecraft leaves Earth's neighborhood and commits to a path that will carry it all the way around the moon. The spacecraft follows what scientists call a free return trajectory, a figure-8-shaped path that uses the gravity of both the Earth and the moon to naturally guide the crew home. This means that even if something goes wrong with the engine, the laws of physics themselves will bring the astronauts safely back to Earth. By day 5, Orion enters the moon's gravitational influence, and on day 6, the crew will fly around the far side of the moon, passing within approximately 4,600 miles of the lunar surface. For several breathtaking minutes, they will be completely cut off from Earth, with no radio contact possible, alone on the far side of our nearest celestial neighbor. What happens next is a gentle, gravity-assisted return home. After swinging around the moon, Orion will arc back toward Earth over the following days, gradually picking up speed as our planet's gravity pulls it closer. On day 10, the crew will face the most dangerous part of the entire mission: re-entry into Earth's atmosphere. The spacecraft will slam into the air at roughly 25,000 miles per hour, and friction will heat its outer surface to a searing 5,000 degrees Fahrenheit. The heat shield, the very component that engineers spent years perfecting after the Artemis I concerns, must perform flawlessly. Then parachutes will deploy, slowing the capsule to a gentle 17 miles per hour, and Orion will splash down in the Pacific Ocean, where Navy recovery ships will be waiting. As this extraordinary voyage comes to its end, these 4 explorers will have traveled farther from Earth than any human in over 50 years. And they will have proven that humanity's road back to the moon is finally, beautifully open. As we bring our exploration to a close, let us take a moment to reflect on what Artemis II truly means, not just as a single mission, but as the opening chapter of a much larger story. Everything we have discussed tonight, the colossal rocket, the ingenious spacecraft, the historic crew, the breathtaking trajectory, all of it serves a purpose that extends far beyond a loop around the moon. Artemis II is a test flight, yes. But it is a test flight that paves the way for Artemis III, currently planned for 2028, and when astronauts will actually land on the lunar surface for the first time since 1972. And beyond that, NASA envisions building a small space station called Gateway in orbit around the moon, a permanent outpost where astronauts from many nations will live and work. The implications of this are staggering. The moon is becoming not just a destination, but a doorway to the rest of the solar system. And perhaps the most beautiful part of this story is how it connects all of us. When Victor Glover, Christina Koch, Reed Wiseman, and Jeremy Hansen look out their window at the moon growing larger before them, they are seeing what our ancestors saw when they first looked up from their campfires thousands of years ago. The same moon, the same ancient light, the same quiet wonder. But now, for the first time in a generation, humans are close enough to reach out and almost touch it. This mission reminds us that we are, at our core, a species of explorers, curious, brave, and endlessly driven to discover what lies just beyond the horizon. So as you drift off tonight, carry with you this thought. Somewhere out there in the velvet darkness of space, 4 of our fellow human beings are sailing past the moon, and they are carrying a little piece of all of us with them. So let the gentle pull of sleep take you now, just as the gentle pull of gravity guides Orion home. Dream of silver moonlight and distant horizons. Dream of the explorers who came before and the ones who will follow. And know that as long as we keep looking up, as long as we keep asking questions, as long as we keep daring to venture into the unknown, the universe will always have another secret waiting for us just around the next bend in the stars. Good night, dear explorer. The cosmos will be here when you wake.